is Nurul Nadia. I'll be bringing you through this EMATS 4016 O-Levels video course. So this is the first module on numbers and algebra, and we are at the first video on numbers and four operations. So the numbers and four operations encompasses 5 sections. So let's jump right into the first section on primes, HCF and LCM. So what is a prime number? A prime number is a whole number that has only two factors, and these factors has to be different. And these factors are usually 1 and the number itself. The opposite of prime numbers would be composite numbers, which are whole numbers that has more than two different factors. A special case that we want to look at is 1. So when we talk about 1 and we want to consider whether a number is prime or composite, we look at the number of factors. So let's look at the number of factors of 1. One can only be factorized into 1 times 1, and these may be two factors, but these are two of the same factors, which essentially means that 1 only has one factor. Because 1 only has one factor, this means that it is definitely not a prime. What about a composite number? If prime numbers require two different factors and composite numbers require more than two factors, because 1 only has one factor, this means that it is also not a composite number. So how do we find out if a number x is a prime? So I have two examples here of 24 and 41. So we will find out if 24 is a prime and 41 is a prime. So first we find the square root of x. So take the square root of 24, which is about 4.89. So we find the smallest prime less than or equals to that square root. So the square root is 4.89. The smallest prime is 3, because 4 is not a prime number. So list all prime numbers less than or equals to that prime. All prime numbers less than or equals to 3. So we got 3 and 2. Then we check if x can be divided by any of those prime numbers, whether x can be divided by one of those prime numbers that we listed. So we look at 24 over 2, 12. This means that 24 can be factorized into 2 times 12. Therefore, 24 is not a prime. So we do the same check with 41. Square root of 41 is around 6.40. Smallest prime would be 5. So all prime numbers less than or equals to 5 would be 2, 3, and 5. So we check if x can be divided by any of these prime numbers. So 41 divided by 2 would give us 20.5. This is not a whole number, so we reject it as a factor. 41 over 3 would be equals to 13 and 2/3, also not a whole number. 41 over 5 is 8 and 1/5, also not a whole number. So we see that when we divide by all these prime numbers, we do not get whole numbers. So none of these prime numbers are factors of x. Therefore, 41 is a prime number. So now that we know what prime numbers are, we can talk about the difference between prime factorization and factorization. What does factorization look like? Factorization just looks like dividing a number up into its factors, no matter whether these factors are prime or not, because we know that 32, 4, 16, and 8 are definitely not prime numbers, but this is the factorization of 64. When we talk about the prime factorization, this means that we are dividing the number up into only its prime factors. because 2 is a prime number and a factor of 64, this would be the prime factorization of 64. So prime factorization refers specifically to the product of a prime factor. What can we use prime factorization for? One of the things that we can use it for is to find the square root of a cube root of a number. So same thing, we find the prime factors of x. So in this case, x is 400. So the prime factors would be and then step 2 is to express it in terms of index notation. So let's express this in terms of index notation. Then we find roots. So now it depends on whether we want to find square roots or cube roots. So let's take the square root of 400. So means we are taking the square root of 2 power 4 times 5 squared. So when you want to take the square root of a number, you divide the powers by 2. Here the power is 4, we divide it by 2. The power is 2, we divide it by 2. The square root of 400 would be 20. So as you can guess, square root, you divide the powers by 2. Cube root, you divide the powers by 3. So 4096, if you express it in terms of its index notation with the prime factors, you can find out that it is 2 to the power of 12. So if I wanted to take the cube root of 4096, I will be taking the cube root of 2 power 12. Cube root, you divide the powers by 3. So 12 divided by 3 would be 4, which is equals to 16. That is how you use prime factorization for square or cube roots. When we use it to find highest common factor or lowest common multiple, these are the other set of steps that we use to find HCF of LCM. So we express your numbers in terms of index notation with prime factors, and then we align the same factors. Now, this step is not necessary but helpful to determine the powers that we need to be taking. What do I mean by align the same factors? Let's look at this example. We look at the example of 12, 30, and 50. So 12 is equals to 2 squared times 3. 30 is 2 times 3 times 5. And 50 is 2 times 5 squared. So you can see that 12 has 2 prime factors, 30 has 3 prime factors, and 50 has 2 prime factors. So what do I mean by align the factors? I mean that 30 has a factor of 2, so it goes under the 2 column. It has a factor of 3, it goes under the 3 column, and it has a factor of 5. 50 has a factor of 2. However, 50 does not have a factor of 3. So we skip this column and we put 5 in this column. This is how we align our factors. So when we want to find the HCF, let's find HCF first. We are looking at smallest power and we are looking at common factors. What does this mean? 2 is a common factor because all 3 numbers have the factor 2. So 2 is a common factor and we take the smallest power, which is 1. 3 is not a common factor because there exists a number that does not have the factor 3, so we ignore it. 5 is not a common factor because there exists another number that does not have the factor 5. So since 2 is the only common factor, this makes our HCF 2. For LCM, on the other hand, it doesn't matter whether the factors are common or not. We take all the factors and we take the largest power, which is equals to 300. So those are the steps when you want to find HCF and LCM. There are different kinds of numbers, and this is a diagram to show you which numbers are subsets of other numbers. So when we talk about integers, integers are whole numbers. So all whole numbers that range from your negative to your positive, like negative 7, 21, negative 1, 1, 17, and so on and so forth. So all integers are rational numbers. And what are rational numbers? These are numbers that can be expressed in terms of fractions. So these fractions need to be expressed as a whole number over another whole number. So P and Q are integers. So let's take an integer. Let's take 21. 21 can be expressed as 21 over 1, can be expressed as 42 over 2, and so on, which is how all integers can be expressed as a fraction when you take the numerator as 1. That makes all integers rational numbers. So what are rational numbers that are not integers? Half. It's a very common number that we see, which is rational because it can be expressed as a fraction, but it cannot be expressed as a whole number because half is 0.5. So or things like 3/4 and so on and so forth. So all rational numbers are real numbers. So real numbers is anything that you can find on the number line. Anything and everything. Real numbers can be separated into rational numbers and irrational numbers. So any number that cannot be expressed as a fraction. So the most common irrational number that we see is pi. We use the approximate of 3.14, we use the approximate of 22 over 7, but in actual fact, these are just approximations, and pi is an irrational number that cannot be expressed as a fraction. So there are two ways that we can round off numbers. We can round off to decimal places, or we can round them off to significant figures. The first decimal place is the first number after the decimal point. So if I wanted to approximate this number to 3 decimal places, what I would do is I would take the first 3 decimal places and look at the 4th decimal place. It is a number less than 5, therefore there needs to be no change to my 3rd decimal place. If I wanted to approximate this number to 2 decimal places, this is my 2nd decimal place, I look at my 3rd decimal place. It is a number that is larger than or equals to 5. What does this mean? This means that my 2nd decimal place has to increase by 1. So we look at significant figures instead. Significant figure is different from decimal place because it is the first non-zero number from the left. It does not take into account your decimal place at all. So first non-zero number from the left is my 6. If I wanted to estimate this to 3 significant figure, first, second, third, I will look at my 4th. It is a 5, which means that my number needs to increase. So in this case, first non-zero number from the left would be 4. So if I also wanted to approximate this to 3 significant figures, first, second, third, you look at the 4, there has to be no change. When we talk about standard form, there are 2 criteria that we want to make sure we fulfill. That A stays between 1 and 10. It can be equals to 1, but it can never be equals to 10. And n also has to be an integer. It can be a negative integer or a positive integer. So let's look at an example of 125. How do we express a number in standard form? The first thing that we look out for is the decimal place. So in this case, the decimal place appears after 5. We want to form a number that is between 1 and 10. So this means that my decimal place needs to move to be between 1 and 2, because then I will form a number of 1.25, which is between 1 and 10. So now I have to figure out what should my n be. Your n should be the number of spaces that your decimal place moved. In this case, the number of spaces will be 2. But how do I know if it's a positive 2 or a negative 2? Moving it to the left means it is a positive value. We look at this example. I'm moving it 3 spaces to be between 7 and 5. So now I have 7.51, which fulfills the criteria of being between 1 and 10. It has moved 3 spaces, so it should be 3, but it moved to the right, which means it should be negative. There are 9 laws of indices that make solving exponential equations slightly easier. When you multiply or divide two numbers that are of the same base, you can add or subtract the powers together. It is when you bring one power to another power, you multiply the powers together. So law 4 and 5 looks very similar to law 1 and 2, but the thing here is that the power is the same instead of the base. So this is when your power is the same. Anything brought to the power of 0 is 1. If you have a negative power, to change it to a positive power, you bring it to a fraction. And when it is a fraction in your power, the denominator becomes your root. So in this case, for law 9, we use law 3, and we see that this becomes that. And then we can apply law 8, take the mth root for a. And this is how you use the laws of indices. Another thing that you will need for exponential equations is the equality of indices. If you have two indices that have the same base and they are equal, you can assume that the powers are the same. So this is very important when you want to solve type 1 questions where you have a power x equals to b, such as 2 power x equals to 8, where 8 can be expressed as 2 cubed. So 2 power x equals to 2 power 3. We have the same base, therefore x equals to 3. So the second type of equations that we will find are simultaneous, where there will be two variables in one equation, but there will be two equations. What does this mean? This means that you have 2 power x times 2 power 3y equals to 1. And then you have 3 power 2x divided by 3 power y equals to 9. So from each individual equation, you can find an equation in terms of x and y. And using these two equations in terms of x and y, you solve them simultaneously. So this is where your skills outside of indices also comes into play. And the third one is called substitution, where you cannot use any of the laws of indices to help you simplify the equation. Such an equation is an example that you will see. So what we do is we let 3 power x be any new variable that you would like to form. So in this case, let's use a. So I have 2a squared minus a plus 1 equals to 0. So we see that now it is no longer in the form of an indices equation, it is in the form of a quadratic equation. Then we can use one of many methods to solve this, and we find a value for a. And when we find the value for a, we let this value, let's say it is 1. So we let this value, and then we solve for x instead. So those are the 5 sections of numbers and 4 operations. We did primes, HCF and LCM. We talked about the different kinds of numbers, integers, rational and real. We talked about approximation and estimation, where we round off to a certain number of decimal places or to a certain number of significant figures. Standard form, where a times 10 to the power of n, your requirements for A and your requirements for n. And then we also talk about indices, where you have the 9 laws and the 3 types of equations. So the next video in our first module, it will be on ratio, rate and proportion. Thank you.